Okay, problem one is find the value of n for which 5 to the 2020 minus 5 to the 2019 plus 5 to the 2018 minus 5 to the 2017 equals n times 5 to the 2017. Okay, the first thing you do when you have an exponent problem is you identify what operation is going on. So here it's clear we have addition and subtraction. Totally different than multiplication, as we'll talk about in a moment. The second issue is whether or not you have any what I call sameness. Do you have a situation where the base is the same? Do you have a situation where the exponent is the same? Because if you do, you will be able to do some combining and some simplification. So here it's clear that the base is the same. So let's talk about what we can do because we have a situation where we have sameness. Okay, so here's the problem written out. Again, it is subtraction and addition, totally different than multiplication. For example, if we had 5 to the 2020 times 5 to the 2019 times 5 to the 2018, etc., we have a situation where the base is the same and we are multiplying. That would have allowed us to keep the base the same and add the exponents, etc. That would have been easy. But that's not what we have here. We have addition and subtraction. The rules are much more stringent in general in math with addition and subtraction. For example, when you're dealing with fractions and you have 1/2 times 1/3, because you are dealing with multiplication, you are just allowed to multiply straight across and you get 1/6. But it's not the same if you have addition. If you had addition, you have to go ahead and get a common denominator. And you have to change this to 3/6 plus 2/6 and then add them. So addition in general in math is more involved. You have to do more before you can proceed. Same thing with subtraction. Okay, so what can we do here? Well, the first thing you want to notice is that the end answer has 5 to the 2017. So can we change these to 5 to the 2017? Yes, we can do this. What we do is we set up individual situations where 5 to the 2017 is involved. Sorry. What am I doing? Where am I? Yep, 2017 minus 5 to the first times, no, I'm sorry, that's wrong, minus 1 times 5 to the 2017. Okay, now in a situation like this, you always want to go back and check your work. Okay, you want to make sure that since we are now multiplying with a common base and we're adding the exponents, you just want to double check you did your math right. So 5 to the third times 5 to the 2017, you would add these exponents and get 5 to the 20th. Okay, we checked that we got the correct sign, which is minus. Next, 2 plus 17 is 19, correct. We check the next sign, it's plus, correct. 1 plus 2017 is 2018, that's correct. Our next sign is correct. And here, there's only a hidden 1 in front of the 5 to the 2017, so we are good to go. Okay, now where do we go from here? Okay, now, this is a situation where you have to recognize that the 5 to the 2017 is just an entity. It's something. In other words, you could say, I have 5 to the third of something minus 5 to the second power of that same something, etc. Or you could look at it this way. I have 5 to the third cinder blocks minus 5 squared cinder blocks plus 5 to the first cinder blocks minus 1 cinder block. So now what do? I simplify. 5 to the third is going to be 125 cinder blocks minus 5 squared is 25 cinder blocks plus 5 cinder blocks minus 1 cinder block. This simplifies to 100 plus 5 minus 1 simplifies to positive 4. So we have 104 cinder blocks. What is our cinder block? It's none other than 5 to the 2017th power. I really should put them in blocks. So our final answer is going to be 104 times 5 to the 2017. Therefore, n equals 104. Okay, let's move to the next problem. Okay. A man enters a building on the first floor and runs up to the third floor in 20 seconds. At this rate, how many seconds would it take for the man to run from the first floor to the sixth floor? Okay, very important in this situation to get it straight that when you run from the first floor to the third floor, you're only moving 2 floors. When you're running from the first floor to the sixth floor, you're moving 5 floors. It's like saying when you go from first grade to sixth grade, you advance 5 grades. You have to be careful. So let's talk about how to do this problem. As always, I find it very helpful to do diagrams. So let's do that. Okay, so we have the man entering on the first floor, and we have him running up to the third floor. In doing so, how many floors does he traverse? Answer, he goes from here to here, that's 1 floor. Here to here, that's a 2nd floor. So he traverses 2 floors in a total of 20 seconds. They want to know how many seconds does it take, so let's put x seconds, to go 5 floors. So indeed, if we start on the first floor and go to the 6th floor, we will traverse a total of 6 minus 1, or the distance of 5 floors. If you're not sure, put in some hash marks. 2, 3, 4, 5. So here's the 2nd floor, 3rd floor, 4th floor, 5th floor. How many floors does he traverse? 1, 2, 3, 4, 5. So now you have this simple proportion set up. where you have 2 floors is to 20 seconds as 5 floors is to x seconds. Whenever you have 2 fractions separating each other with an equal sign in the middle, that is a license to cross multiply. So that's what we're going to do. And we're going to have 2x equals 100, x equals 50 seconds. Okay, there's another way we can do this problem that might be helpful on some future similar problem. And that's to use the concept that rate times time equals distance. So in the first scenario, they tell you that in 20 seconds, the gentleman runs up 2 floors. So what is your rate? Your rate is going to be 2 floors for every 20 seconds. Then we come down here in scenario 2, where the person is running at the same rate. So we go ahead and we plug that in. The same rate we got from the first scenario, times the time, which we're trying to find, equals the distance, which is 5 floors. We solve for t, and we get our answer. Okay, t is going to be in seconds. T seconds. So now we realize we got our units right. Because if we were to cross out seconds here, we would get floors equals floors. So now that our units are correct, we can just put the numbers down here and do our math. Again, 2 fractions facing each other with an equal sign in between, we can cross multiply. Okay, let's move on to the next problem. Here it is. An old video game, which I believe is Pac-Man, features this hungry creature. And they want to know the perimeter of the creature. So they're looking for this distance here. And they tell you that this mouth has a central angle of 60 degrees. And then they say, do not round your answer. So let's go to the other screen. And this is what we have. They want this distance here. That's the perimeter of the Pac-Man. Now, it would have been nice if this was just a circle. Then we could have just got the circumference, because they do tell us that the radius is 1 centimeter. I believe it was centimeters, yes. And we could just find the circumference of that very easily using the formula that circumference is pi times the diameter. But that's not what's going on here. A portion of the circle has been removed. Now the question is, what portion of the circle has been removed? Well, 60 degrees of the circle has been removed. So 60 degrees out of 360 degrees has been removed. 1/6 of the circle has been removed. Therefore, this circumference portion of this circle from here to here is going to be 5/6 of what the total circumference would have been. The total circumference would have been pi times diameter. I'm sorry, that doesn't look right. This will be the blue. that you see. 5/6 of the circumference. So what is the circumference? The diameter is going to be 2. So the circumference is going to equal pi times 2. And if we do 5/6 of the circumference, it's going to be 5/6 times 2 pi. So that's going to give you 10 pi over 6. So that represents the blue from here all the way around to the other side to there. But it doesn't include the 2 radii. No problem. Just add those. And we're done. So this is the total perimeter of the Pac-Man. Now, here's the hardest part of the problem. They say, don't round your answer. I really don't know what they mean by that. Does that mean leave it in terms of pi? Does that mean use pi equals 3.14 and write down 50 numbers, infinite number of numbers? Or does that mean use pi equals 22 over 7? So what I do in this scenario is I do all 3 because I'm not sure what the teacher wants. So I'm going to give him or her all 3. So this would be one way to leave it in terms of pi, but I think we can do a little bit better. So we have 10 pi over 6 plus 2. Okay, we can reduce that to 5/3 pi plus 2. And we can put a hidden 1 here. We have a denominator of 3 here, a denominator of 1, and we're adding. Therefore, we need to change this to a denominator of 3. How do we do that? In my opinion, the best way to do that is to multiply this by 3 over 3. Why is that legal, what I just did? Because 3 over 3 is just 1. So I came along and I multiplied this by 1 in a different form, namely 3 over 3. It's completely legal. So that gets us 5 over 3 plus 6 over 3, or 5 pi plus 6 over 3. Okay, so that's a simplified version that includes pi. And again, I don't know if that's what the teacher wants. If we plug in 3.14, actually, if we plug in pi, the symbol pi, from our calculator into here and do the math, we end up with this mess. 9, 8, 7, 7. Is that what your teacher wants? I don't know. So let's do the third one, where pi equals 22 over 7. So let's see, my original equation was this. 10 pi over 6 plus 2. And this time we're going to use pi equals 22 over 7. Okay, we're going to take this and plug this in for pi. Okay, a lot of times students are unsure what to do right now. Do they, the 10 and the 6 they know, do they put the 22 over 7 like this? Is that legal? Well, in cases like this, if you're not sure whether it's going to be this or whether it's this, I find it helpful to take this expression and expand it. Okay? So what we're going to do is we have 10 pi over 6. That's the same thing as saying 10 over 6 times pi over 1. And if you're not sure you did that right, go back and check. You could multiply straight across, you get 10 pi over 6, and that's indeed what you started with. Okay, so now you have this. Because you expanded things out. You can eliminate that hidden 1 and say 10 over 6 times pi. What are we using for pi? We're using 22 over 7. So now you know you did everything completely legally. And it turns out that yes, you could have done that. You could have put the 22 in the numerator and the 7 in the denominator. But again, if you're not sure, don't hesitate to expand things out. Sometimes that clarifies things. Okay, so now we're back here. And we have 220 over 42. Is that the final answer she wants? He or she wants? Well, actually, would have to add the 2. Almost forgot about that. So can we reduce this before we do any addition? Yes, this is the same thing as 110 over 21 plus 2 over 1. Okay, same scenario. How do you get this denominator so that we can add them? Answer, we multiply by 1. Always legal. Any day of the week and twice on Sunday, you can come along and multiply that by 1. But in that format, it doesn't help us. In this format, it helps us. So now we have 110 over 21 plus 42 over 21 equals 152 over 21. So that is a situation where we have it in a fraction, which is not rounded, and the answer was in centimeters, by the way, and centimeters to the first power, because we're dealing with perimeter.